So we are here for the last session of the Al Medina track here at JNation. It's almost a wrap. So for this last session here on the track, we have Tom Granot. He works at Lightrun, and he calls us from Israel. And he's going to talk about getting back to sleep as soon as possible to for the on-call developers. So you are going to tell us an horror story of someone that will get wake at the middle of the night and has to solve an unsolvable problem almost. Let's see how it's going to go.
Excellent.
Go
Thank
for
you.
it. I will talk to you for the questions later.
Excellent. So hi, and thank you, Bruno, for the warm introduction. I'm so happy to be here at JNation, albeit online, hopefully soon, not so much online, but also in person. This talk is a personal favorite of mine. I love it. It tells a story and then does also technical stuff during the way, which is always fun and games for everybody involved. A bit about myself before we hit the road. My name is Tom. I'm a solution engineer here at Lightrun. We build real-time observability tooling for developers by developers. If you want to reach out to me, you can do so over Twitter, best preferred medium. You can also do it via GitHub, I guess via a GitHub issue, but that would be very non-ergonomic. So maybe just use Twitter instead. You can also find me on my email, tomg@lightrun.com, or visit our website, lightrun.com, and play around with the product. We have a free tier. So jumping right in, I want to tell you a little story about OASIS. OASIS is an enterprise system. It is a piece of software built by an enterprise to be used by an enterprise in order to do enterprisey stuff. It has a management console. It has many different services. It does a bunch of stuff. Most of them not very interesting. Some of them really not interesting. But still, it makes a lot of money for the company that built it. They can charge a lot of money from the customers. The customers are happy because they have a management console with many enterprise things that the enterprise likes. And everybody's happy, including the developers building the software and getting paid to do so. Being a big enterprise worldwide system, OASIS is active 24/7. It's always live. And because of that, we need people in order to support it while it's live. And this, in most modern organization, kind of splits apart into a few different groups. So you usually have a developer who is on call, maybe one, maybe more, who are in charge of actually dealing with application logic. So something is really, really wrong with the application. They would figure it out, debug it, and push it back into action. In addition, because of the amount of complexity in most modern applications, you also have a DevOps engineer or in addition, usually a few support engineers that man the front line and and basically debug various application level problems that are, let's say, can be codified in a runbook. They will talk to a customer and try and push buttons and twist knobs in order to do different things in the application. The DevOps person is usually in charge of the infrastructure beneath. So things like the Kubernetes cluster the application is running on, maybe EKS if you're running on AWS, maybe bare metal servers, or if you're running on an on-prem data center, then they will also deal with that too. And in addition, that varies. Not all organizations have it, but a lot of them have NOC teams. And NOC teams are people who sit in front of screens and basically make sure to monitor the metrics of the applications, the services, and notify when something goes wrong. So this is how OASIS looks like. A developer on call, a DevOps person, and a couple of support engineers manning the stations, in addition to the NOC team. Now, I want to talk a little bit about the system itself, because we are going to go through a bit of a scene here. Basically, we're going to see exactly what happens during some random on-call night. And I want to talk about how the system is built, because you have not built OASIS and you don't know OASIS because it is an enterprise system that nobody out of the enterprise knows. So I want to tell you a little bit about how it's built in the inside. So first and foremost, it's a microservices-based system. It's written in Java using JHipster, Spring, common Java technologies for enterprise applications, for applications in general. OASIS is comprised of different types of services that do a bunch of different things. There's a gateway up front that directs traffic around. You have an inventory service that's in charge of keeping track of inventory. You have a transaction service that is in charge of making transactions between different parts of the application. Basically, a user will ask a request, and then a transaction will be created, usually billing of a credit card or something of that sort. And there's also a credit service, which is an external service that is in charge of swiping credit cards, basically. gathering payment information, collecting it, and then charging the cards. There's a fraud checking system and a billing system, a bunch of different things that happen in the system. And to monitor it all, there's a very standard ELK stack. I think it's called the Elastic Stack now. And that stack is in charge of basically ensuring that the DevOps team, the developer, the on-call people, everybody can have a great grasp on what is going on inside the production setting. Now, in real life, on-call is a pretty bad situation. A lot of the times things happen and you really, even the most prepared teams sometimes face things that are completely unexpected. And I like this little picture of a bunny because it depicts something that happens during the bad on-call sessions. You're working and everything's fine. Maybe you mitigate a small problem. And then out of nowhere, there's a huge storm coming in over some random thing that went wrong and then cascaded throughout the system, which you have to debug in production live via the application, throughout the shift in order to basically fix it on the fly. Now, in real life, there's a big separation of concerns between the different types of people who do different types of things in the on-call situation. So first of all, the DevOps engineers, they know system. They're infra people. They're sysadmins at heart. And they know how to tell when the application is misbehaving on the infrastructure level, i.e. the infrastructure is failing beneath the application. And they know what to do in order to fix it. And many DevOps engineers today are actually programmers. And they also know how to deal with infrastructure as code things that are relevant to your application. So they will actually know a pretty significant portion of the infrastructure that runs your application, but they will still be limited outside of the context of application logic most of the time. Usually they deal with things that are, let's say, on a lower level of the stack than the developers writing the applications. Support engineers are, again, it varies between organizations, but a generalization would be that support engineers follow playbooks either written by them, following incidents in the past, or playbooks that were written by developers who wrote the system in order to, again, push button and turn knobs in order to fix various things in the application. This can be something like restarting a specific service or sending a specific API call, maybe clicking some button in the management console. Each system has its own type of support and support engineer privileges orientation. And it is really important that these people are very technically savvy, and a lot of the times they know how to solve most of the problems themselves. But again, they're segmented to, let's say, the front part of the application. They have their buttons and knobs, but they're siloed in a way. The environment itself is super duper noisy. Lots of noise coming out, and not just from the systems themselves, the logs, the metrics, the notifications in Slack or whatever it is that you're using. Maybe you have a PagerDuty connected to your phone that's ringing off the hook. But generally speaking, you would note that when something happens, a lot of functions in the company get involved. So if an account director or an account executive whose customer is complaining of a problem will usually hop on the phone and yell at you to fix it while the customer is complaining. Or maybe the person on the other end of the line is actually the customer himself, and you're talking to them, trying to debug the problem as you're listening to them on the phone, trying to understand what's going on, if you have a few major clients and not, a lot of small ones. And this means that whenever there's a remotely complex application logic problem that cannot be solved by any of the people, that I mentioned before, in addition to the fact that the environment is kind of super noisy, it's kind of hard to understand what's going on, there is a switch you can press in order to rescue the situation. And that's basically calling the developers. You tell them, come in, your application is crashing, please help, everything is messy, we don't know what to do, come in and help. And that's what the developer on call is expected to do in an on-call situation. Now, I want to introduce you to Jamie. Jamie is your common enterprise Java developer. Jamie has about 5 years of experience or so, or something like that. And Jamie specifically works on the service that is in charge of transactions. We talked about the services before. He works on the transaction system and is in charge of writing the service and obviously being on call for it when something bad happens. Now, assume that Jamie is currently on call. There's a shift going on, you're inside of it, and the transaction is failing for some reason. The support engineers are looking at the transaction from their own perspective, from the management console, and try to understand exactly what they can do in order to fix it. They try and they fail. They can't make it work. So if they fail and they can't make it work, there are other functions that are getting involved in the process now. You have the DevOps team that are saying, okay, let's look at the metrics of the infrastructure beneath the application in order to understand what's going on. So they go in, they see nothing in the monitoring systems as well. And because, again, whenever there's an issue with supposedly remotely complex application logic, who you're going to call? You're going to call Jamie. Now, Before we dive into the actual demonstrations part of this discussion, I want to talk a little bit about the concept of observability. This is a buzzword being thrown around a lot lately. And Lightrun, the company I work for, builds things that help with real-time observability. So I think a definition is in order. So the best way to define it is building a system that talks, and talks in a way that gives you the full picture. And specifically, the kind of core definition of it is observability can be defined as the ability to understand how your systems work like on the inside without shipping new code. And the important bit here is the without shipping new code, because we can always add more observability to a system. You add a log line, you deploy, you push to production, you wait for the release to roll, and then your logs will roll in either into the STD out of the application, or maybe your APM or whatever integration you have set up with your monitoring system. Now, this is not obvious. Not everybody are building systems that are observable by default. A lot of people build systems and treat observability, the way the application will talk to you once it's running in production, separately from the development of the application. Log lines are added as an afterthought, metrics are instrumented only when needed, and the observability infrastructure for your application might not be completely off the bat in the first try. It is running in production, the system is working, the tests are written, they pass when you push into production, the actual system is up, the IT metrics say CPU, RAM, say everything is okay, but the logs and the actual kind of full picture of your application is not entirely clear. When something wrong, there's a lot of missing information. And before we kind of dive into what can go wrong, I think it's great that we can talk about what can go right. So the things that our tools do tell us, what is actually happening inside the application that our tools can tell us. So let's do a quick review. First and foremost, logs are an excellent way to understand the state of your application. There's a log. By the name, you can tell that it logs whatever happens in the system. And if you go at it one line by line, you can understand exactly what's going on inside your application. Well, at least the things you wrote in order to understand what's going on inside your application. But it does provide a pretty good picture. Logs solve 50, 60, 70% of major problems. You look at the logs, you understand what's going on, you push a hotfix, go away to sleep. Another set of important information is IT metrics. I'm talking about CPU, RAM usage, how much load is on the machine at any given point of time. Those are infrastructure metrics used by the DevOps people of the world and the sysadmins of the world. And they tell us how the infrastructure the application is living on feels. And this is also a big part of the question, and perhaps solves another big portion of the issues that come on. Maybe some service is crunching RAM. You don't have to fix it at that specific point in time. You just have to know that this is the reason the machine is acting up. There's too much memory being consumed. And then you can, again, by the support engineer or whoever is in charge of this infrastructure, this operation at this given time, do some things, usually prepare for it, in order to fix when that happens. Perhaps there's some auto-scaling feature at play. Depends on the organization. I don't want to get into it too much because this is not a DevOps discussion. In addition, there's this little subset of metrics that is called differently in different places. Some places call it a service metric, some call it a business metric. I'm basically talking about things like how fast your APIs are responding, how much failure rates they get, things that will most likely be written inside the SLA, the service level agreement between you and your customers. And these are things that are very telling of the way your customer views the application. And again, we are getting paid for what customers are experiencing, a big gap sometimes between what we as developers think and the real world. But the eventual thing is that the thing that matters, the thing that brings our company money and keeps us on the payroll, is how our customers feel the application is behaving. And service metrics is one way of measuring these things. Another type of tooling that is very common, it's actually not a new concept, but it's become very popular with the whole cloud native movement that we've seen lately, is tracers. And I'm talking about things that allow you to trace how much time it took specific parts of the code to run. And you have a bunch of them. I think the most popular one are maybe Zipkin and Jaeger these days, I guess since not sure when Zipkin was released, but these are kind of the more popular known open source ones used in many different companies. And they, again, really help you in understanding how an API endpoint is behaving at any given point in time. Like what's actually taking too long to run? Is there some other downstream method that is causing the downstream API call that is causing the problem? Is something wrong with this service that cascades down to that service? It's a great way of understanding what's going on. In addition, you have profilers, and profilers are notoriously expensive to run in production. It's things that you don't, maybe you have a sampling profiler or something like this, but it's just an expensive performance-wise piece of tooling to run continuously. A lot of people still do, and it's a great way to understand what's going on with the state of the application. But again, they have their limitations. They do tell us in many ways, I'm thinking about tools like Visual VM, for instance, tell us how a specific portion of the application is feeling in depth. It will tell you exactly what is happening inside the context of the application at any given point. But again, they're expensive to run, and sometimes they don't provide the full picture because they do sampling and not full profiling. One extra piece of tooling that is obviously a crowd favorite is debuggers. Debuggers are usually not used in production. You have remote debuggers, obviously, that you can attach to a machine. Many companies completely forbid connecting remote debuggers to production machines because of obvious security considerations. It's a production machine. You don't want to stop it from running while you're debugging. And the concept of remote debugging a lot of the time applies also when you're trying to fix the problem locally. So what I'm getting at is you will reproduce the problem you see in production locally, and then maybe use the debugger to step by step kind of run through the application in order to understand what's going on. Step in, step out, step over, and understand what's going on inside the application. One extra bit of tooling that is, again, not new, but has a lot of value in many organizations today is exception monitoring tools. And I'm talking about things like Sentry, for example. And these are things that allow you to aggregate all the information about errors and exceptions that happen in your application, and then understand kind of what's going on whenever they happen application-wide. And these are great for understanding what's happening when something goes wrong. They don't often tell you what is going on while things are going right, but kinda. So when things are not absolutely terrible, they are not really helpful. Or when an exception or an error is not being thrown, they might prove not to be as helpful. Now, I'd like to take a moment to kind of re-examine observability. So in my definition, the definition I gave you before, observability was defined as the ability to understand how your systems work on the inside without shipping new code. What I'm saying is that we need a better definition for that. I'm not going to go into it just yet, but I'm going to tell you that we are going to define it later on in a way that's a bit more applicable to real-time debugging, what we do kind of as a professional side gig when we're on call. And I really want to focus in order to explain why this matters and why building the systems in ways that are observable matters. I want to tell you about the gaps, the things our tools don't tell us. So first and foremost, GASP, programmers makes mistakes, and you can end up with incorrect application state at different parts of your application. This is not straightforward, but sometimes the state of the application is corrupt. You got to a point where things are not as they were expected to be. That might be the test that this code was the test that were written for this code might pass and everything work, but the eventual way the application is presented to the user is not what the user expected it to be. The state of the application is incorrect, either from the user's perspective or because we hit some barrier inside the application that we did not expect. And this is very common, again, due to programmer errors, but sometimes you're totally working in accordance to what product has told you. No bugs are actually apparent in the application. The application itself looks okay, but from the perspective of the customer, something is wrong. Maybe a button that is supposed to appear is not appearing. Maybe the load on the machine is very high, and it is causing the machine to create some sort of weird state. Basically, anything has to do with bad application logic. But speaking of performance issues, I want to step into something that's a bit nuanced. So we talked about tracers and how they allow you to look at methods and understand exactly what's going on, sometimes on the method level, sometimes on the API endpoint level. But the bottom line is that there's a whole set of metrics that we instrument a lot of the time inside our code. Think about things like the sizes of data structures in memory, for example. It's not always obvious to understand how much values are in that object. How much does it weigh? How much things are in this array at any given point in time. And these are things that, how much time it took a few lines of code to run, how much time did you reach a specific line of code in the relevant flow. These are all quantitative type information that is really interesting to understand, but we don't always have instrumented beforehand. So we kind of have a black box there. I want to add a new code level metric, and I really can't because I don't have it instrumented yet. I would have to instrument it, then maybe perhaps even push a new version in order to deploy it, configure it in the APM, and so forth and so forth. One extra thing that's a nice kind of problem that appears a lot, especially in legacy code bases that were written with many different developers working on the same code simultaneously, swallowed exceptions. That's basically the case where an exception was thrown, but the description was not there. So it was thrown and caught, but nothing actually was emitted into the logs. You would not know that the exception actually happened. If you have exception monitoring tools instrumented, then you might get them, you might not, depending on the tool. But the bottom line is that from the perspective immediately, when you're looking at the application in real time, it's not clear that this happened. An exception was thrown, but you can see it in the visible log of the application. I'm going to go ahead and make an assumption in the next block here, which is you are using outside APIs for your application. And this is a common statement for basically any modern application. We sometimes use APIs that are not ours. And that can be an external billing service. It can be just some geocoding service. It can be basically any type of external service that is more useful to buy than to build. And they sometimes misbehave. And while they have their own kind of I guess, license to operate, do you have an SLA with them? Sometimes they throw back information that is wrong, or you send them something and they give back a response you did not expect for. And this can be maybe because they updated a version. This can be perhaps because something is going on their region of AWS that has nothing to do with you, but you are affected by it directly. It's basically a whole slew of issues that can happen from factors that you cannot test for and you cannot align for because you have not prepared for. It is a third-party API that you have not built yourself. You have no hands in it. You can't understand what's going on inside of it. You just have to deal with the consequences. Now, speaking of consequences, a nice little bug appeared in GitHub a while back. It was a big on Hacker News. I'll drop the link in the Slack JNation afterwards. Basically, what happened is a user logged into their GitHub account. GitHub is a big VCS. I don't think I need to introduce GitHub. That's a very popular tool. But GitHub had a user sign in. And when they signed in, if I remember correctly, what happened was they saw the organization and the repositories of a completely different user. This had to do with some sort of caching issue. What I believe happened was the credential that was cached was incorrect, and then there was a race condition inside one of their services that sent back the incorrect response to the credential process, to the authorization process, sorry. And then the user ended up in a place they're obviously not expected to be. And this is much more common than we would like to admit. Not logging into different organizations on GitHub, hopefully that is not really common, but finding users that are in a place in the application where we did not expect them to be. This can be perhaps looking at a table that is incorrectly populated. This can be perhaps clicking a link that leads to a different part of the application. The most common one is just a 404, right? Some bad page, but it's a lot of more nuanced things can happen. For example, you load the state of the full organization for a specific user, and then the user has some sort of components or things on the page that they did not expect to see, maybe in the wrong order. Maybe they set a preference somewhere in the code and you did in the settings and you didn't apply it because of some problem. Basically, it would be very hard to understand how the user is feeling without using tools like in SaaS situations like Hotjar or FullStory to basically understand the full user flow. But from the backend developer's perspective, that's just a black box. The user is obviously experiencing some problems. They will tell you. They are very vocal. But it will not be obvious for you just by looking at the application. One extra thing, speaking of race conditions, is the nature of how we run our software. A lot of the times, you will not have multiple resources touching the same thing very, very rapidly at any given time. It happens for some applications, not for all of them. But when they happen, sometimes the resource will send out different responses depending on who got there first. Race conditions is a whole big issue. I'm not going to get into it because it's a full discussion. I want to write a talk about it at some point because it's such an interesting discussion. So if you want to send me some bad race conditions you saw in the past, please do. You know my information. But the bottom line is that they happen so indeterministically that it's really hard to understand what's going on in the application just by looking at it. It's impossible to see, wait, there's a race here. You always understand it and kind of collect the pieces in order to better to understand that this is actually a race. And one last thing, we're working with the cloud today, and we're working with multiple replicas of the service running on multiple pods or whatever it is you're running or you're orchestrating your software on. And we develop our software in front of a specific machine. We work on our container on our machine or on our project or on our process or whatever we're working on it on our machine, and we debug and develop it against our own machine. The implications of running the same replicas of the same service across running multiple replicas of the same service at any given point in time are things you don't often account for when you're developing. And this can have weird consequences. Maybe some containers are spinning up and down rapidly, and that causes some sort of weird bug to trigger some edge case in the application logic. Lots of bad things that can happen when you push your application to the limit, and we need to account for it. And again, it's not obvious that the problem is the infrastructure. Sometimes the apparent problem is the application logic, when actually what happens is the infrastructure beneath it is acting up. Now, I do want to stop the chit-chat and jump into a quick demo to actually show you what it looks like in practice. And I just want to kind of remind you that this is an on-call situation, which means somebody has called and said, or pinged or whatever, and said there's a problem. This is the ID of the user that is currently having the problem. One of the core problems that any sane developer would say here is that, wait, are you using numeric IDs in your application? Yes, unfortunately so. This is a legacy enterprise application, and the person who architected it did not think to use things that are, to use ID that are not just simple numeric ones. But hey, that's what we have, and we're gonna debug with what we have. So I just wanna remind you about the stack of the application. So we have a bunch of services and an ELK monitoring stack. We're gonna watch it in a bit. Everything is already instrumented, running, and working in production. I just want to understand what is going on with that user. So what do we actually do when we know the ID of the user, but we're not sure exactly where it is in what actually happened to that user? We go to the logs. So as I mentioned, I've instrumented Elastic here, and this is the logs of the application. As you can see, there's a lot of logs going in, a lot of information coming in. I don't actually know exactly what all of these things do at any given point in time. There is too much cognitive overhead here. So what I'm going to try and do is I'm going to try and filter for the specific user ID inside the logs and see what's up. So I'm going to copy and enter. And then I can see that in the past, I guess that was around an hour and something ago, which means I got to the problem pretty slow. But anyways, I'm looking at the application and I can see there was a bunch of information coming in from that code. For that user. And I'm just going to follow all the relevant things that are happening inside the log, just go bit by bit. There's a bunch of services here, then there's a bunch of log lines. And you can see that the first line for that user at 2347, the topmost it's sorted by time. It's that it started to process the purchase for the user. Great. So I'm seeing that the logs are actually starting to work. Basically, what I expected to happen actually happened. The purchase has been started to The purchase was starting to process. And then there was the same service is trying to validate a transaction. That also looks OK. Then a credit check is happening in another service, which implies an HTTP call somewhere in the realm. Then there was a fraud check. Then there was a starting to bill credit card thing. And then they try to actually perform the billing. And then I can see that they actually finished doing all the things. So finished performing billing, finished billing credit card, finished checking for fraud. And basically all of the services that started running have succeeded. Yet the customer implies, or basically tells me up front that, hey, I have a problem here. The transaction is not going through. So imagine yourselves in this situation. What can you really do? Unless you know exactly which service has caused the problem. And in this case, specifically, Jamie is working on a transaction service. He knows roughly how all the other services are behaving, but he doesn't know exactly what is happening here. It's kind of hard to understand. So in order to best debug the situation, what we usually do is look at the code, see exactly what happens inside the ID, inside the source code for the specific application. So I actually have my ID ready here, IntelliJ, a very popular ID, and I have actually the first service, the inventory services resource opened up. For those of you who don't know, this is just a controller. It's the standard way you do things in Spring microservices. And I'm going to look at the code and see what's actually going on. And I can see that there's a log info that is similar to what I'm seeing in my own in the Kibana. But there's also a transaction service call here that goes to some HTTP client. The FAN client calls another API to do something. And I'm going to look at the method and see exactly what is going on with that method. And I'm looking here, and it looks like it's doing another call to another service, which is the validate transaction in the transaction resource. Okay, let's move on to the transaction resource. And I can see that the transaction resource unsurprisingly logs and then moves on to another service, the credit service, which checks the credit. The credit service obviously works from the credit resource. I'm going to go into the credit resource. It also logs a bunch of stuff and then checks for fraud. Very simple application logic here. It is just for the sake of demonstration. I'm going to check the fraud, and the fraud resource is what actually does the call. I'm looking at the fraud resource, and for some reason, I'm noticing there's an interesting little method here that actually does the check for fraud. And I'm looking at the method, and voila, there we have our swallowed exception. Now, this is, if you're not familiar, this is an interesting Eclipse thing. This is basically what happens when you auto-generate a try block catch inside Eclipse and then forget to actually add the log statement for the catch block. Now, this is not something that will be actually pushed through a proper code review. But a lot of the times, you're in a rush. You need to push a product out, or you need to basically be involved in the kind of organizational effort to promote the things forward. Quality standards go lower, and then you end up with things like this checked into your VCS with nobody actually checking the to-do items down the line. Now, this is a great example of something that is easy to detect in a code review, how to pass over, easy to pass over when you're in a time crunch, but not apparently obvious from the logs. If I look at the logs, you can see that this is actually not evident. I can't tell that this happened, but an exception was swallowed, and I was stuck dealing with the mess at 3 a.m. in the night. So let's conclude. We talked about what bad things can happen in our application, or more precisely, what bad things can happen in application that our tools won't alert us to. I just showed you a demo of the swallowed exception, which is just one example of this thing. And I want to define this new concept of observability. We like to call it continuous observability. So in the same way you have continuous integration, continuous deployment, observability should be a continuous process too. And if observability can be defined as the ability to understand how your systems work like on the inside without shipping new code, continuous observability can be defined as a streamlined process for constantly asking new questions and getting immediate answers. And the key point here is the streamlined process. What happened here was that I had a new question. I did not know what was happening because the logs were not telling me the full story. I had no streamlined process for asking new questions. I had to scroll through my code, file by file, line by line, in order to understand what is going on. And this was a very simple application with a very simple bug. And in most applications, you have hundreds and thousands and tens of thousands of lines of code in each of your places in each of your files and packages in the IDE, which is a nightmare to navigate. And you don't even know where to begin to debug, so you end up doing sort of a binary search, trying to go with, okay, so it's not on that half of the desert, maybe it's in this half of the desert. It's a big old thing. So just a quick shout out. I mentioned Lightrun a few times in this discussion. An observant watcher, or somebody with eyes, will notice that I'm fully swagged at the moment. We have a nice blazer here. The green room guys at JNation right before the conference made sure to mention that I was the best speaker in JNation. I'm going to hold the title dearly to my heart and going to apply it to my resume everywhere from now on. So while I'm already swagged up and all dressed up, I think that the best way to kind of talk about my product is after we laugh for a bit, a tiny bit of a shout out. We build real-time observability tooling right inside your IDE. You can add real-time logs, metrics, and traces to your application from your IDE, see exactly what's up. In this case, you would be able to pick a log line somewhere, pick a code line somewhere in the IDE, right-click a button, add the log, have it pushed directly into production, see the information right in your IDE. Check it out. We have a free tier at lightrun.com. And between my sins, I am a solution engineer. So if you will reach out, open an account, and try to implement it in your company, you will meet me again, which will be awesome. So moving on. What can you do to be better at on-call? And I have about 5 more minutes before I have to drop into the Q&A. So this is an excellent time to wrap up the conversation. So what can you do to win at on-call? On-call sucks. That's fine. You have to choose to love it. It's totally a perfect and normal part of the job for your normal developers. That's just part of life. And instead of being, oh no, I have to wake up and have PagerDuty installed on my phone tonight. Instead, what you should do is you should be happy that your company has such a great product that users are using it 24/7, and you will always have, and you have such a big responsibility for kind of the appearance of the product to the outside world. I know I I'm deeply proud of the company I work for, and for me, having a way to contribute in the kind of support sections that I take on from time to time is really great. I really enjoy it. I choose to love it. Extra point, you should be ready. So your laptop should be ready. It should be charged if you're not in front of a charger, connected to Wi-Fi, Slack should be on, VPN connected. Everything you have to do in order to get involved in the process needs to be handled before the session. This really helps. It's kind of like having a bash RC for your on-call procedure. It would be really helpful if you could have some sort of preset configuration on your machine to do that. When I was a site reliability engineer before I joined Lightrun, I was working with an Ubuntu box. I had a nice little Lenovo T490, and we had basically just a text file that we would, it was actually some sort of idempotent script, if I remember correctly. We just kind of, not idempotent, sorry, a dump script that we would kind of enter through and do a bunch of things in order to prepare for the session. It was really nice for the on-call session. I really like this type of tooling, things that make it easier to jump into the process. So gear up. And there's a fallacy that developers believe that this is an edge case that will only happen to me. It will never happen again. No. It will happen again. Document it, write the commands you ran inside the console so the other person next to you who will be in the same position 2 weeks from now will not have to suffer through the same problem. Better yet, tell your support engineers about it. Tell them that there was a problem. Tell them how you fixed it. They're smart folks. They will take this and they will learn better to do their jobs. It really matters, this communication. Speaking of last company I was in, we had these emergency debugging tools, which are basically scripts that you run in order to understand things in your production applications. These are things that kind of instrument metrics on the fly or add logs or maybe restart specific containers that are usually acting up. Maybe they swap some sort of file underneath. It really depends on your application, but it's really useful to have them, again, in your bash RC. I can't emphasize enough the importance of postmortems. Every single great response team I know has amazing, detailed, lengthy postmortems. It helps everyone involved, by the way, including your product team, which will be really interested in seeing the weird failures they can expect and then build the next features on top of them. Basically, make sure that the next features are built in a more resilient way. It matters organization-wide, and you should try and promote it as much as possible. And the last thing, generalists, and I pride myself at being a generalist, have a problem. We think we know everything. And this is unfortunately not true. The DevOps person next to you knows more about the infrastructure than you do. If he says or she says something, listen. And when you're not sure exactly what the problem is, hand over things that are outside of your realm of control to the people who are in the context, they're in their own zone. You should make sure to enable them and empower them, even if they're not developers, to do their job properly. And this, I think, out of all the points in this talk, and I mentioned at the beginning, I really like this talk. It combines the technical and the storytelling in a way that speaks to me. This point at the end is important. You're part of an organization, and you need to understand that. You need to understand that, to be a great person on call, your job is not to be the smartest person in the room. Your job is to be the best team player. And this, again, matters in the long run. And I hope you take the time to learn how to be one. So this was me. This is also me here in the presentation. Hi. As I mentioned, I'm a solution engineer for Lightrun. You can reach out to me over at my Twitter, Tom Granot. GitHub is also Tom Granot. Email tomg@lightrun.com or sign up for the free tier account on our website. On a personal note, before I move on to the Q&A session, this time with COVID is problematic for everyone. I hope you and yours are safe and sound. And I really, really hope that the next time we see each other will be in front of one another, maybe with a glass of beer in our hands. Thank you. Bruno?
Hey, Tom. So I wonder if you have any observability data on that claim that you were the best speaker ever.
Yes.
At JNation.
So obviously, right before the session, I added a log to a process called Filippo, and the process called Filippo, who is, by the way, the person running the green room for the organization, for the team here, gave me back information and told me, yes, you are the best speaker in the conference. Just saying, it's a true claim.
That's great. We will be able to assert that later.
Yes.
When we are debugging the conference.
Exactly. You're doing a post-mortem of the conference, which is a great idea.
Oh, that's for sure. That's for sure.
Excellent. Excellent.
So Tom, so we don't have any last questions.
Okay.
But so I have some questions. So remember that you mentioned that it's really hard to assert the size of big data structures. So in my experience in Java, the only way to do that, it's actually getting a memory dump from the process.
Correct.
Yeah, so my next question would be, so do you have any other way, is there any other tool that could give us a lightweight estimation without having to actually do a memory dump of the whole thing?
So I have to do a plug here. I'm sorry, I have to. But the core of the product that we build is built for this type of scenarios. You have a thing in memory that you want to build, you want to get at, and you can add a log or a metric or a snapshot and look at the object in real time without stopping the process. So basically what you would be able to do is, for example, we have a mechanism called a light run metric. You can add any type of code level metric you would like, for example, the size of an object, or maybe the more useful information would be to see the actual values inside the object, to understand why it's exploding so fast. You can do that with a light run snapshot. But this is not a product pitch, despite my confusing swag. Not what I want to do here.
Yeah, but for example, will those metrics be outputted into only your product, or are they available, for example, following OpenTelemetry, the OpenTelemetry standard?
Excellent question. So, and again, I didn't want this to become a product pitch, but if you're already asking, so the bottom line is that
I'm asking. I'm very curious.
Hey, I'm sold. I'm biased, obviously, but I'm happy you are too. The bottom line is that we actually output the information, the raw textual information, into wherever you'd like. We have an IDE plugin that pipes the information there. We have integrations with Datadog, New Relic, Elasticstack, basically a bunch of different integrations that we can pipe information into. But the simplest form is that we can dump it into a file. And then you can have something like FileBit collect the files and basically push them wherever you want, maybe into some APM collector or whatever. So anywhere you want the data to be, it will be there.
Okay. So I think that's a wrap. Tom, thanks very much. You are the last speaker here. We will be. There are still other talks running in other tracks. And for you guys that are still here, I invite you to switch to the other tracks, because in the end, we'll have 5 minutes to say goodbye, all of us, and for the last thoughts on this conference. So Tom, thanks very much for being here, and I hope we can see in person in the near future here at Coimbra, Portugal, for one of the next JNations.
I will be very happy to do so. Thank you very much for having me.
Thank you. Bye-bye.